Welcome back, dear 7th grade. 2 video days in a row. This cannot get any more exciting. Oh, maybe it was Wednesday you had the video. We missed math on Thursday, didn't we? Oh, well. Anyway, we got something new and special today. This ought to be a lot of fun. If you would please take out a blank piece of paper. I think we haven't talked too much about this. Maybe we have. Maybe you've got something on this, but if you would write on top of it, proportions. Proportions. Or you could do equal ratios. Proportions, ratios, it's all the same. Let me find my page back in my math book. Sure, here it is. Proportions. Alrighty, here we go. Oop, wrong pen. Proportions. And the little subheading under this is solving them by cross products, which might make you cringe and say, what in the world is that? Let's turn the Wayback Machine a little bit back and look at this problem here. Let's start with what we know about proportions or equal fractions. When we talked about this, let's say you have 1 over 2 equals the letter M over 8. Okay, you should look at this and go, well, that is an incredibly easy problem, because simply when we solve proportions or equal fractions, which are the same thing, all we have to do is do this. 2 times what number is 8? I multiply by 4, and then 1 times 4 is the answer to the top, which M equals 4. Okay, and that's all well and good if you can figure out 2 times what number is 8. Occasionally we come across equal fractions, equal proportions, equal ratios that don't work out quite as neatly or as smoothly as that is. For example, if I gave you the problem 5 over x equals 7 over 8. Okay, here would be, if you're trying to solve it that way, you'd go, 5 times what is 7? Which gives you a big fat question mark, which is why we talk about today by cross products. And here is something to understand about fractions. Let's go back to this one here. I know that 1/2 equals 4 over 8. The deal is, when you have equal fractions, equal ratios, equal proportions, there's a well-known fact that says this: when you multiply the diagonals together, 1 times 8 equals 8, and you multiply the other diagonal together, you get the same number. The diagonals multiplied together are equal, which means when you solve something by cross products, what you are doing is you're making an equation and you're setting the diagonals, are going to be equal. So this looks like this. I usually try to do the one that has the x first. I take 7 times x, and that has to equal whatever 5 times 8 is. Now let me tell you, generally speaking, if you have to do it this way, you are not going to get a pretty answer, because if you were to get a pretty answer, you probably could have done it this other way over here and it would have worked out nicely. So this comes about when you don't get such pretty answers. So here I end up with 7x equaling 40, which is an equation. How do we solve a multiplication equation? You simply do the opposite and you divide. I'm going to divide by 7, and I'm going to divide by 7. This, believe it or not, is my answer. You probably want to simplify it, and I would leave it as a fraction. Sure, if you want, you could change it to a decimal, but that's going to complicate all of our lives. 7 goes into 40, 5 times, which is 35, and then there's 5 left over. So 5 and 5/7 is what this letter x over here would have been. And again, the reason why it is not work out is because you couldn't do that thing the other way. Now, a couple things to keep in mind. Sometimes you might think you need to use cross products and you may not have to. For example, if you come across this problem, m over 10 equals 15 over 25. Okay, you really have your option on this. Cross products would work. Let's do that first. M times 25 is 25m, and that has to equal what this diagonal times that is, which is 10 times 15 is 150. This one's not such a bad problem. I divide 25 into 25 and 25. How many quarters are in a buck and a half? Well, that is 6. So my answer works out nicely as 6. But if I go back to this problem again, let me rewrite that. M over 10 equals 15 over 25. One thing maybe you could have noticed over here is 15 25ths could be reduced. I can divide those both by 5. And if I divide them both by 5, I get 3/5. And if I get that equal fraction, I can forget about this fraction, and I could use this fraction for my proportion. And this one does work out. Look, 5 times what is 10? 5 times 2. And then 3 times 2 would be 6, which if you look is the same 6 I got over there. So your choice. Sometimes it's easier to do the proportion, sometimes it's easier to reduce, kind of up to you. Let's do a couple more example problems because I can tell you are just chomping at the bit for this. How about this one? X over 4 equals 6 over 9. To which you might say, hey, I could reduce 6 9s. Yes, you could. Let's divide them both by 3. The new fraction I get is 2/3, but you know what? That really doesn't help me out because 3 times what gives you 4 doesn't work. So in this case, cross products are in order. I multiply the diagonals. And like I said, I usually do the x term first since I get my choice. 3 times x has to equal 2 times 4. So 3x equals 8. I divide by 3. I divide by 3, and this is my answer. Again, not pretty, but it is, if you change it to a mixed number, it is 2 2/3. Just that easy. By the way, you will use cross products a lot in your life. One more. 5 over 6 equals 11 over m. This one doesn't reduce, so I am stuck with really no option. I'm going to change colors because these reds and blues are getting kind of boring. No option but to use cross products. I multiply 5 times m, and that equals 6 times 11. Simplifying that, I get 5m equals 66. The multiplication equation again done by division. I divide by 5, I divide by 5, and 66 divided by 5 is 13 1/5. So the letter M equals 13 1/5. Hopefully, ladies and gentlemen, that gets you everywhere you need to go when we're talking about proportions and all that stuff. Have yourself a great, I believe we'll be having a weekend after this. I think this will get shown on Friday, even though right now it's a Tuesday. Have a great weekend, 7th grade.